So what would your acceleration be if you sped up from 8 meters per second to 25 meters per second while traveling 400 meters? All right, so why don't we start by figuring out what information the problem gives us. What givens do we have here today?
The initial velocity,
Yeah, and what's the initial velocity?
8 meters per second.
Right, so it starts at 8 meters per second. That's its initial velocity, the VXI. Good. What else do we have?
Final velocity,
Yeah, and what's its final velocity?
25 meters per second.
Right, so that's how fast it's going at the end. That's our VXF. One more given, right? What's the other thing we know?
How fast to accelerate, or no, it would be how fast you sped up.
Well, that's what we're looking for, right? Because it says, well, the last thing, right, is while traveling 400 meters. If he's traveling 400 meters, what quantity does that tell us?
Distance.
The distance, right? So that's how far he goes, right? So that's our distance or displacement. That's our delta x. So we've got 3 givens. That's good. What's the unknown quantity in this problem?
Your acceleration.
That's acceleration, right? It's asking us, what would your acceleration be, right? So AX, that's our question mark. All right, so we've got VXI, VXF, delta X, and AX as our givens and unknowns. So which kinematics equation would we use to solve this? Which one has exactly those 4 quantities in it?
The second one. Wait, no. Second one's missing.
Right, not the second one. Because of the second one's got time instead of displacement, so it's not that one.
The last
so
one.
it's the last one. Yeah.
No, that's right. It's the last one, right? The last one's got VXI, VXF, delta X, and AX in it. So I'll copy that one down. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. And it looks like we are going to have to do some rearranging today, right? Because we want the acceleration all by itself here, but it's not all by itself yet. So what's the first thing we have to do to get acceleration by itself? We're going to need to take a couple of steps here. Anybody want to take a guess as what the first thing we should do? Or does anybody know what's the first thing we should do? A hint would be, sorry, go ahead.
Divide the acceleration on both sides?
We don't want to divide yet because we have this other piece here, right? So what we're looking for, the AX, is in this piece, this term of the equation here. So we want to get that whole term by itself first. So what's preventing that is this VXI squared. How can we get rid of this VXI squared from this side of the equation?
You can subtract it.
Exactly.
On both sides.
Yeah, thank you. That's right. We subtract it on both sides. Right, so we do, if we do minus VXI squared on this side, then we have VXI squared minus VXI squared, and that goes away. And we have to do it on the left side as well. So what I have is final velocity squared minus initial velocity squared is 2 times acceleration times displacement. Now there's only one more step to get the acceleration by itself, right? What should we do now so that we only have AX over here? Remember, the 2 and the delta X are being multiplied onto it.
Divide them.
Yeah, so that's right. So now we divide them, right? So to get AX by itself, we'll have to divide by that other stuff, by the 2 and by the delta X, right? Because now we have 2 over 2, that cancels out. We have delta X over delta X, that cancels out. Of course, we have to do it to this side as well, right? So divide by 2 and delta X on this side. So that gives us our rearranged equation. Turns out acceleration is going to be final squared minus initial squared over 2 times our displacement. Okay. Now that we've got it rearranged, we can go ahead and plug in our numbers. Right, our final velocity was 25. So 25 squared minus our initial velocity, which was 8 meters per second. We'll have to square that. And then we'll divide that by 2 times 400 meters. Okay, so I'll do, let's see. I'm going to put the numerator in parentheses here, and I'll do 25 squared minus 8 squared, and then I'll divide that by 2 times 400, which I'll put in parentheses as well. And I get 0.7. 0.7, and the units I have are, if I've got meters per second both squared divided by meters, I end up with meters per second squared, which is good. That's the unit for acceleration. And 0.7 meters per second squared isn't a big acceleration, but it takes it a while to go from 8 to 25, so a pretty small acceleration seems reasonable. Anybody have any questions, comments about how we got that answer or any part of it? Okay, great.